So that actually brings us to the end of the POMDP topic. So
How do we know we're at the end of the POMDP topic?
We have high probability of believing that we're at the end of the POMDP topic because the observation that we're making is the what have we learned slide. So what have we learned?
Well, we learned about POMDPs.
Partially observable Markov decision processes.
Well, we had been exposed to these things before, but we really kind of dove into sort of some detail about what they are and how to solve them. And in particular, we've talked about belief states. As kind of a representation, which represents the states that we might be in and how much we believe that we're in them. We talked about POMDPs as a strict generalization of MDPs, which is sort of important, and that if we can solve a POMDP that happens to be an MDP, we will solve the underlying MDP. One of the unfortunate consequences of all that is that dealing with POMDPs is hard. They're hard to solve. They're just sort of fundamentally difficult. I can't remember the exact result now, but there was something in there about undecidability.
Yeah.
And that was difficult. That was hard for me to deal with.
It was hard for you to accept. Hard to accept.
Right. Despite the fact that it's hard, we did come up with some algorithms for solving MDPs, like value iteration. I remember something about piecewise linear and convex.
Right, representing value functions as piecewise linear and convex functions.
Or PLC. And one of the things that was nice about that is that you showed that you could build up these sets of kind of linear functions, and because you only cared about the max at any given point, you could throw away a bunch of them that might be unnecessary.
Good.
And sort of keep the hard problem possibly manageable.
Good.
That was really nice. Then we went from the solving of POMDPs to reinforcement learning with POMDPs. And if solving POMDPs is hard, then RL for POMDPs definitely has to be hard. And that turns out to be true. But we tried to do it anyway. Let's see, we did memoryless.
First, we talked about a model-based method.
All right, model-based method.
Where you try to actually learn the POMDP from experience wandering around in it.
Right.
And do you remember how we did that learning?
With a great difficulty?
Well, sure. We talked about expectation maximization as a way of trying to organize that computation.
Sure, that's a favorite of my expectations.
Your maximally favorite?
Yeah, my maximally favorite one. We got to go all the way back and try to remind ourselves how EM worked.
Yes.
That was fun. And then we did memoryless?
Yeah, and that we needed, in the memoryless case, we might need to be random.
So again, just like grad school.
I don't think that's true. You're saying that if you're in grad school, but you don't remember where you are in grad school, then it helps to act randomly.
Well, it certainly explains the behavior of some of my grad students. Okay. Then we had, we probably did more stuff there, but I can't remember it. And so I do remember, though, that we started talking about Bayesian RL.
Yes. And the cool thing about Bayesian RL being that it blurs the line between planning and learning. So, and Bayesian stuff does that in general, this sort of notion that, well, all learning really is estimating probabilities of things. It's not actually, learning. So it just keeps changing your posterior. And so decision-making in the Bayesian RL setting ends up becoming just a kind of version of planning in a continuous, ugly kind of POMDP.
Speaking of which, if we have Bayesian RL, do we have frequentist RL?
Well, sure. I mean, Bayesian and frequentist are kind of, rivals in a sense. So anything that's not Bayesian maybe is frequentist.
Okay.
So all the other reinforcement learning that we did, like Q-learning and whatnot, it certainly has a frequentist flavor in that, what is frequentist statistics is about? It's about, counting up how many times something happens and divided by the number of times you asked. And that is, definitely Q-learning has that flavor. Model-based RL where you're trying to estimate the parameters of the model from experience, they tend to have that flavor.
Okay, so good. So then we have been learning about frequentist RL, and now that we have Bayesian RL, it reveals the frequentist things that we had been doing in the past. So I'm okay with that.
Yeah, and the Bayesian RL is very nice because it doesn't make an exploration-exploitation distinction anymore. You're always acting given your knowledge of what the truth is, and you're acting in a way that maximizes your reward given that knowledge.
Right, and so exploration is exploitation.
Ooh. Planning is learning. Exploration is exploitation. War is peace.
And we have always been at war with supervised learning.